Hello, everyone. Welcome to a SharkNet New User Seminar. In this seminar, we will walk you through the basics of using the resources provided by Digital Research Alliance of Canada. Across the country, there are four consortia providing the resources and the support to researchers from across the country. We have the west area covered by formerly WestGrid, and in central Canada or Computer Ontario, Calgary, Quebec, and to the east provinces covered by AceNet. And what is the SharkNet? The SharkNet is a consortium of 19 Ontario institutions providing advanced research computing resources and the support. SharkNet is a member of Alliance and Computer Ontario. Currently, there are over 3,000 Canadian and international users frequently use our resources on a daily basis. And the SharkNet has about 50,000 CPU cores and over 500 GPUs for researchers. And between the main sites, the 10 gigabit network is available that allows data to be transferred at a high speed. This gives you an organizational structure across the country. Across country, there are four consortia: the West, Computer Ontario, and Calgary, Quebec, and AceNet. And within Computer Ontario, there are four organizations: SharkNet, SciNet, Center for Advanced Computing, and HPC for Health, which covers the hospitals and the research institutions in the Great Toronto Area. And here are the places that you can go and look for information. One is the website, Research Alliance of the website, docs.alliancecan.ca, where you can find the information like how to get started, running jobs, and what software packages are available, and many other things. And as well, if you go to SharkNet website, and you can find information like training events, some news, and other things. Continue where to look for information and to get help. And every Tuesday at 2 o'clock Eastern Time, we're having this new user seminar primarily for new users who just sign up for an account. And weekly, we have a Computer Ontario colloquia at noon on Wednesday on different general interest topics. And you can also find recorded seminars, talks, and the lectures on our YouTube channel. If you go to youtube.sharknet.ca, you will find pre-recorded the videos. And also, you can subscribe to our event mailing list if you want to receive the notification for events and the news. What other help you can get? For interactive help, you can send email to support@tech.alliancecan.ca, or if you have questions regarding the SharkNet and regarding the resources operated and help provided by SharkNet, you can also send an email to help@sharknet.ca, and your email will generate a ticket automatically, and your tickets will be picked up and dealt with by our staff members. And again, you can also send us an email, and you can check our staff contact information by going to SharkNet website. On the SharkNet website, you can find our staff members and our background and expertise. Okay. And before pandemic, or hopefully we can get out of the pandemic soon, you're welcome to stop by, have an office visit, and we can help you with the use of systems, installation of software, access to commercial software and the site licenses, debugging and optimizing your code, and programming support, and the grant applications, and other things. The facilities and the resources are available in the three categories: HPC clusters, clouds, and the storage. For the cluster and the cloud, currently we have 5 clusters across the country, from the west to east: Cedar, Graham, Narwhal, Niagara, and Beluga. In the cloud services, we have Arbutus, Cedar, Graham, and the east. Now, just notice that for the clouds, you have the name.cloud.ca. Now, please note that files are not shared across systems, which means if you have used one system, for example, on Graham, and then nextly move to another system on Niagara, then you would have to copy the files from Graham to Niagara and vice versa. The computing environment, all the clusters are running a 64-bit Linux operating systems, and we support the major programming languages such as C, C++, Fortran, Python, R, MATLAB, Octave, Java, Julia, and CUDA, and many other things. And you can also access to a variety of software packages. We'll come to that in a few moments, what software packages you can have access. And for parallel development support, primarily we support the Message Passing Interface, or MPI, OpenMP, which is a multi-threading based programming paradigm, and CUDA for GPU, OpenACC, OpenCL for accelerators. And the program language C++ has its own support for multi-threading. This is something new added to the languages standard since C++ 11. And the Fortran, this is a very old program language, but it supports parallel programming since 2003. And you can write your parallel program in Fortran that can run on a cluster across many compute nodes or servers. And the Julia is the emerging new programming language for scientific and parallel processing, and it can run on shared and distributed system as well. And for data science support, we have Python, and we have people in the software packages to support your data science research. And on the cluster, people will use batch computing through the scheduler slurm, which means you do not run your program interactively on the cluster as you do on your laptop or desktop. You would instead submit your program along with your data to the scheduler and tell the scheduler how long it will take for your program to run, how much memory your program might need, and where to run. In which folder you want to run, and the scheduler will find available resources and start your program there. And once your program is finished, and the scheduler will let you know or save the result in the files. This picture shows in the workflow of how one uses a cluster. So you log in from your laptop or desktop to the logging node of a cluster. A cluster may have a one or more logging node. And on the logging nodes, you prepare your program, data files, and other things. And then you submit your program to the scheduler, and the scheduler will put your program in the queue, and your programs are called the jobs, and they will be sitting, waiting in the queue for the resources to become available. And once the resources, whether the CPUs or GPUs, your program can start and on the compute nodes. And your program will run on the compute nodes assigned by the scheduler, and then will run to the end. Once your program is finished, the scheduler will generate a report, and that you will get a notification if you choose to do so. And on the cluster, all the compute nodes will have access to this huge storage, and this is a place that you can store your files if your program generates a lot of data. Now, how to connect to clusters? There are a number of ways of connecting to clusters. For Windows users, we recommend the free software Mobax term. It combines an SSH client. For SSH stands for secure shell. It contains a SSH client to log into the remote systems, and then FTP, a secure FTP client that allows you to copy files, and as well an X Windows server that allows you to run graphical applications on cluster and displayed on your local computer. And Linux and the Mac users can use the command line tools, SSH, scopy, and rsync that are available to the system. And for Mac users, running graphical applications remotely requires a free software, Xquads. Okay, this is just a brief summary of how to connect it to remote clusters. If you are using a external or a mobile external and to connect to the remote cluster. Now, one thing just keep in mind, if your username on the local computer is different from your username for the cluster, you need to provide a login name. So the command is SSH remote cluster name space dash L space your username, or the other format is SSH your username at cluster name. So both way work. So next, transferring the files or large amount of files using Globus. You can use scopy or SFTP to transfer files between your desktop, laptop, and remote clusters. But if you have a large amount of files to transfer between your laptop and the cluster, or between clusters you have used remotely, and the best tool to use is Globus. And for the details of how to use a Globus, you can go to docs.alliancecan.ca and the wiki page and search for Globus. This will enable you to transfer files between any two computers either your laptop and the clusters, or between the two clusters. Okay. This is something special for SharkNet. And SharkNet is operating a cluster called Gram. And on Gram, we provide users with a remote virtual desktop, kind of VDI. So you can log into any of those VDI nodes on the Gram cluster. What you need on your local computer is a VNC viewer. We recommend the Tiger VNC viewer. You install your VNC viewer on your local computer, which is very straightforward. It's a self-contained software. And then once you install, you start a VNC viewer, it will prompt you for the VNC or the virtual desktop address. You type in gra-vdi.computercan.ca or .alliancecan.ca, and you you click connect, and you just follow the instruction, and you will be prompted for username and the password. You enter your username and the password, and then you will finally land on a desktop. This is a Linux desktop remotely on the Gram cluster. Okay, so that's another resource that you can use. And on the VDI, you can run a graphical interface such as a MATLAB, some commercial software, engineering software, for example, the CFD software, or some chemistry and physics software if you need to build your models and do some visualizations, and that's where you go. Next, the concept of file systems, and everyone has access to the following file systems: home, project, scratch, and the nearline. Home is quite small. It has 50 gigabytes for everyone, and it is backed up on a regular basis. And this is a place for you to store your source files, some small data files, configuration files, text files, and documents, and so on and so forth. In the project, everyone has a quota of 1 terabyte by default, which could be extended to 10 terabytes per user group, or 500,000 files. And the project is also backed up on a regular basis. And this is a place for you to store large data files. And for example, if your computational program generates a lot of data during the computation, or it needs to read lots of data during the computation, and this is the place to store your data. So we strongly recommend you start your project, your research project, on the file system project. And we'll come to this later when we do the demo. You'll see where you can find the folder project. Another one similar to project is a scratch. It is identical to project, except for you have a more size quota, 20 terabytes per user, 1 million files, and up to 100 terabytes of storage, but it has a life of 2 months. So if your files are older than 2 months, they will be purged, they will be deleted. Okay, we do not back up any of the files on Scratch. And the Scratch, as the name stands for, it is for Scratch, for saving temporary files. And the nearline is the place to store files not currently in use, but may be needed later. Okay. A project, a Scratch, and a home, these are the locations that you want to store files that will be frequently used. And the nearline is the storage for storing files that won't be used for a while, but it may be needed later. Okay. And you can find more detailed information by going to the website docs.alliancecam.ca and find the storage and the files. Some tips for project space. There's some special requirements for the project space. Generally, we would expect you to understand these. So do not preserve file permissions when you're copying files to project space. So typically, you do not use commands like a copy with an option -p to preserve the original permissions. If you do, it will mess up the file permissions, then you will run into different problems. And as well, you do not move files between different file systems. You copy files between file systems. And for those who are familiar with the command rsync, and you do not use the option -a to transfer files between other file system and the project file system. And tips for nearline space, you can find your file account by typing this command, find. Find is a Unix command. And to find the nearline your account, you will see what your account might look like, and a pipe to Unix command wc space -l to count the number of files. We strongly recommend that the following: you do not edit the files in nearline. If it is on tape, your editor my hand. And the file size, so this is the guideline, at least 10 gig to 20 gig per file. And the ideal file size is somewhere between 100 gig to 500 gig. Okay. So nearline is the place for you to store large files. And as well, we expect that for large files, they are compressed. What software packages are available? There are two ways of finding what software packages are available. You can go to the Alliance documentation page, go to docs.alliancecam.ca and look for available software packages. And sometimes people often come to us and ask, could you please install this software package for us? But before you ask, you might want to do a search yourself. And the chances are the software packages you're looking for has already been installed on the system. So there's no need to install them again. Okay, so this is one place to search for all the available software packages along with the information on how to use them. And as well, while you're on this cluster, you can type the command module avail or module spider, a keyword, to look for software packages available on this cluster. For running jobs, let me just quickly go over 4 ways of running jobs. So there, on this slide, we show the 2 cases side by side. On the left, it shows how to submit a single job. A job runs on a single CPU core. The way you prepare for running a job is this. You create a job submission script. This script is basic Linux shell script. The first line is always like you put the hash exclamation / bin / bash, and you put the second line hash sbatch and space time. This will be your runtime. The format is day dash hour dash minute dash second, and the second you can omit the second because it doesn't make much practical sense. And the second line here specifies the account, the group account. What group account do you want to use? Now, pay attention to this. This is the account. This is the accounting group account, and not your user account. A user may have a one or more group account. For example, everyone has a dev-pi name group account. And some people might have multiple group accounts. For example, you have an RRG-pi name or RPP-PR name if your group has resource allocation from Alliance. And then after specifying these two important lines, in this example, I simply put another two lines. The first one is the module load, a Python module 3.6, version 3.6. And then the command to run my program in Python. Python, my program name, and my program, my Python script takes three arguments: case number, output, the base name, and another case number. Okay. So once I have this script ready, I call it a myjob.sh, save it, and then I run command sbatch from the command line. So this is the way to submit a program to the scheduler. Okay, this script tells the scheduler my program will take an hour to run using this group account. Okay, this is the simplest job submission script. Now, on the right-hand side, this script shows how we can submit a whole bunch of jobs at once. So in this example, I'm going to run 200 cases. And 200 cases in my Python script will take a input, a task ID, and a base name output, and something else. I think this is missing. But anyway, this example shows I'm running a Python script. It takes a task ID, and this task ID is interpreted and expanded by this line highlighted. This line here specifies a job array. And this array has the integers from 1 to 200. Okay, so this line simply just generates an array of 200 integers going from 1 to 200. And those integers will be stored in this variable slurm array task ID. And once the slurm scheduler sees this, it will expand this into the 200 values, and you will run this command repeatedly for 200 times to submit 200 cases. And this is the way of running a bunch of jobs at once. Instead of running on the left, running a job submission script 200 times, and here we just do a one shot, and we specify in this job submission script, specify the 200 cases, and then we can run them. Of course, in this case, you would have to write your program in such a way that it can take an input ID and then to run the program according to the input ID, and then generate an output with the input ID label, so that you do not change your program, but you only change the input and the output, and they will get different results for different cases. This is actually called the serial farming. And a better way of doing the serial farming is to use a meta package. This is written by one of my colleagues, Sergey Mashchenko, and you can find the detailed information on how to use this package for running multiple serial jobs at once by going to this website docs.alliancecam.ca and go to the web page, a wiki page, and look for the keyword meta, a package for serial farming. Okay. So next, submitting parallel jobs. Again, the side-by-side on the left, this example shows how to submit a threaded job. And on the right-hand side, it shows how to submit a parallel jobs that runs on the cluster across nodes. A threaded job will be only running on a single computer or single compute node. It does not go cross nodes, while a general parallel job can go cross compute nodes. Okay, so for the threaded jobs, you define the runtime, you define the account group. Now, the most important thing is you need to define the number of tasks, which is 1. Number of tasks equal to one process. For threaded jobs, you always set the number of tasks to 1. And then you need to define this parameter, CPUs per task, 32. This means one process or one task is using 32 CPUs. This is a typical way of running threaded jobs. And then there's something new, man equals 2 gig. This specifies the maximum amount of memory this process will need. Okay. By default, if you do not specify this, the maximum memory that you can use is a 4 gig on gram. So if your program uses more than 4 gig, then the system will shut your program down or terminate your program. So it is very important to specify the right memory size. Now, you may ask, how do I know how much memory I would need? Well, then you need to in a trial, do some experiment to find out how much memory your program will need. Okay, and this is something you would have to do. For those who are using OpenMP, you might need a specified OpenMP environment variable, and this is where and when you need a specified number of threads. The number of threads here is specified, is set to the number of CPUs per task. This is what you set. Because otherwise, your OpenMP, if you are running a program using a canned applications or software, the chances are it might just grab as many cores available on the cluster, and this is might not be what you want, or might not be what we want as well, because you need to tell the scheduler how many CPU cores you need to use ahead of time, rather than let your program to pick how many cores your program will be using. Because if that's the case, if your program picks how many cores, how many threads it's going to use, and the scheduler will have no idea, and this will mess up the scheduling system. Okay, so it is important to specify the number of threads, and the number of cores ahead of time. Now, for running parallel jobs, this really means running MPI jobs, the jobs, multi-process jobs that can run across nodes. And here are the options, the common options. Again, you put your accounting group, runtime, and the number of tasks or number of processes. In this case, it's 100. And the memory per CPU, this is 4 gig, as I just mentioned. 4 gig is the default. If you need more than 4 gig, you need to specify. Okay. And then for running parallel MPI jobs, multi-process jobs, the command to run is to use srun. Srun in your program. You do not specify at the command line any number of processes or number of cores. They are taken care of by the specification by these lines here. Okay, there are a few commands you might want to get yourself familiar with. SQ, after you submit your program using SBatch, you want to run the command SQ immediately to see your jobs, whether they are in the queue or they are running. And another command saccount to see the job history. Scancel if you want to cancel a job. And this command sef, this is last use command. It can tell you something like about the memory, the utilization of your job. Now, just a high-level view of how a scheduler works. Suppose you are observing at the current time. You're observing the system, and this is the horizontal line is the time axis, and the vertical line is the number of cores of a cluster. And these yellow, the green blocks represent the jobs running from some past time all the way to the future, and the width of the block represent the size of the job. And as we are looking at the system right here, we are sitting at the borderline of the past and the future. And the scheduler will put the jobs submitted to the queue and put in the queue. For example, this yellow part is being occupied by some job. Okay, the scheduler will put over here. And as you can see, there are some empty slots between now and the future. And these empty slots shouldn't be wasted. If they can be used, that would be great. And filling these empty slots is called a backfill. If your job waiting the queue and then your job size and the job runtime can fit any of those empty slots, then the scheduler will try to match, try to put them in those empty slots. So as a result, even though you're waiting the queue and the many people might be ahead of you, but there's still a chance that your job can start earlier if there are free spots. And keep in mind that the situation in the queue might change anytime according to the priority of the jobs. So the scheduler will constantly shift the jobs in the queue and move the jobs back and forth and get some jobs to start and put some jobs still back into the queue. Okay, so this is how scheduler works. And sometimes you might ask why my job doesn't work, why my jobs don't start. Now, on a cluster, any cluster, there are different partitions. There are 12-hour partition, 24 hours, 3-day, and a 7-day partition. And on Cedar only, there's a 28-day partition. And within each partition, again, there are regular memory queue, large memory queue, and the GPU queue. And depending the runtime you specify, the size of the memory you specify, and the type of resource, whether it's a CPU or GPU, your job will be put into different partition, and therefore you may expect different runtime depending on how busy each partition is. And you can use the partition stats to see the system status, which gives you a snapshot of what the current system look like. But as I said, the situation may change momentarily. Okay. So in general, we cannot predict what's going to happen in the next moment. There's some common mistake to avoid. So do not run significant programs on the logging nodes, and do not run programs directly on the compute nodes. And do not specify a job runtime blindly. For example, 7 days. You specify the runtime reasonably. Give a reasonable runtime estimate. Okay. And also, you need to specify the memory, but do not over specify the size of the memory. Try not to create millions of tiny files or large files, not compressed. These are the common practice. Okay. Okay, so this is a short presentation, and the next going to take you to the cluster, and then let's take a look. So first, let's take a look at around. Assume you connected to a cluster. You want to take a look around at the command that you want to use as ls. ls will list the files and directories. So in my case, I type ls, it lists the files and directories in different color, and those in blue are directories or folders. And while these the white ones are regular files, and the light blue ones are shortcut or links. Okay. And if you do not see those colors, you can use the option -F. Now -F option -F will add a slash at the end of a folder, so you can tell which one is folder and which one is file. Okay, and then you can also do change a directory from one place to another. Let's do ls again, and I'll do ls again. You see, I have projects and also Scratch, and these are the places that you can access. You get to the project and the Scratch space. So if I do cd projects, and I see I have some folders in it, and I come out and go to project plural form, and I see I have a 2 group account. And if you do that, and you might see one or more, like if a dev, your PI name, or RRG or RPP -PR name. If I do -BG again, I'm going to my folder. Okay. Okay, let me just go into a folder. This folder is a demo, and let's go to folder serial and list the files and the directories. I have a whole bunch of files there. Let's take a look at the job submission script. Run a job -sh. This is a bash script. Inside the script, I specify the runtime, the group account, and I load the module GCC and the load module R, and the next I'm running an R program. So the R program, the command is R, and the option and my program's got a sample R. Okay, and these are these options after --args, the 3 arguments input 23, which is a case ID, output, that's the name for the output base name. So my program takes three arguments, and this is our program. This is how you run R script. You can either use R or R script for those of you who are using R. Okay. And to submit, I do S batch and run a job. So this is how to submit a job. And in a few moments, and it returns with the job ID. If I do SQ-U VGE, I just want the list of my jobs to see the status, and it shows the job ID and the username, group account, and here is the ST stands for status. CG actually means completed. So then I want to list the files that is just generated. I use the Linux command -L to list the long format, T in the time order, R in the reverse time order. So the last one, this is the generated, the output. If I want to take the content, look at the content of the output, oops. I just type in the name. So this is the content of the output. This is actually from my R script. Okay. Now the next to see module command, the module avail. If I type a module avail to see what software packages are available, it will generate a long list of packages. So you might want to do avail and a pipe to a command more, so you can see a list of a portion of a list at a time. The modules or the software packages are listed in alphabetic order. There's many packages. Okay, many packages in the alphabetic order. If you do module list, it will list the modules that are preloaded for me in my case. So in my case, I have 10 modules loaded. The Computer Canada config environment and the Intel mass kernel library compiler, OpenMPI, the mass, again, that's a message passing parallel development library, and the standard environment. Okay, so now it doesn't see this list. It doesn't include R. So I want to load module R in order to run it. For example, if I just simply type R, it just gave me a list of R to choose, and I can type a name R, for example, 1 to load 4.2.1. So in this case, it loads 4.4.1, and then do module. If I do module list again, actually the R is not loaded. If I do module spider R, and it shows a list of R with different versions. And in particular, if I want to load module 4.2.1, then I can do module load R 4.2.1, and then do module listen again. Then you see I have 4.2.1 listed, loaded. And in the meantime, some other modules are loaded as well, along with R. Okay. And lastly, I want to show you the command partition stats. Partition stats will return a snapshot of the current system status. It might take a few seconds to return to the prompt. Right. Okay. So now the partition stats shows the different partitions. As I mentioned, 3 hour, 12 hour, 24 hours, 72 hour, and 168. This is 7-day hour. The last column is the 28 days, which is only available on the Cedar. Therefore, I am on Graham, so there's nothing there. Now, we have a few different sections. First section, that's the number for queued jobs, and then the number for running jobs, number for idle nodes, and the number for nodes by partition type. And in each section, you will see the jobs, regular, memory, large memory, and the GPU. Okay. And also you have the number. In the number, you have a pair of numbers. For example, 2 column 76, 22 column 826, and this means by node and by core. So by node by core, this means the scheduler schedules jobs by node or by core. By core means if you ask a specific number of cores, the scheduler will schedule your job by core. And as well, you can ask a scheduler to ask for a resource by node. I want a whole node, or I want 2 nodes or 3 nodes completed exclusively. So this is by node. Okay. So these two numbers, a pair of numbers, simply just shows by node or by core job. And as you can see, there are way more by core jobs, the regular jobs, than by node jobs. And sometimes by node jobs might give you advantages of starting earlier, but not always. Okay, I'll just stop right here, and I will leave some time for questions.